called How Good Java Habits Can Encourage Bad JavaScript Habits. And this talk stemmed from, I did an architecture review for a client, and they came from a background similar to you all, and I could just see the same errors or the same bad code over and over again, because you could tell that they didn't understand the difference between Java and JavaScript. Even though it shares the same word Java, it's very different. I've heard a quote, Java is to JavaScript as ham is to hamster. Like, they're obviously different. So again, I'm Elijah. I'm a Microsoft MVP. Work for Apintu, which is a company that's dedicated to jQuery. So we do all front-end development. And you can email me at elijah.manor@gmail. I'm on Twitter, Elijah Manor, and ElijahManor.com is my blog. Which, by the way, this talk is recorded and available on my blog for you to watch. So this talk is based on a set of 3 articles that I wrote for EnterpriseJQuery.com, which Apintu hosts, and it just people seemed to like the topic. In that case, really the same points apply to C# and Java. I know that the languages are different, but the concepts apply for either one. So the first concept we're going to talk about that is a bad habit is Java developers don't understand that there's something called falsy values in JavaScript. Whereas you might be familiar with, when you write an if statement, you usually want it to resolve into a Boolean, false or true. But in JavaScript, there's a lot of different, there's 6 different values that could be rendered as false. And these are considered falsy. So one is just a Boolean false, which everyone probably understands. Obviously that's false. Null can be considered false, which, that kind of makes sense. There's something undefined. In JavaScript, you don't really have to define all your variables, so that's considered false. And this might be a little surprising, is an empty string is considered false if you were to test it in an if statement. 0, which if you ever did, just raw C code, you might remember that. And then there's something not a number. It's just not a number. So these 6 things are all false. Anything that's not these 6 things is true. So an empty object is true. The string false is true. It's a string, and it has a length, so it's true. So the next several points are going to piggyback off this concept. And one of them is not testing or setting default values correctly. So something you might see based on your knowledge of Java, you might, in JavaScript, you might test something that's not null and it has a length. That's just kind of a common thing that, you always want to test for null because you don't want to have that object reference null error. But you don't really need to do that in JavaScript because of falsy values. So just like we talked before, null was false, empty string was false, undefined is false. So really all you have to do is just check for the variable. And what it does behind the scenes, it makes sure it's not undefined, null, or empty. If it does have a value, then it gets inside the if statement. And so this is the way you would see JavaScript libraries testing for this. They wouldn't actually check for not null and length. They just do it like this. So this is considered better code, just because you understand what a falsy and a truthy value is. You also see some code like this. If you come from JavaScript and you want to set a default value, you don't have to, test for null. Because just like we said before, there's ways to do that a little bit better. So instead of testing for null and then setting a default value, or doing some crazy ternary operator, it's not null, set this value. If it is null, set default value. Instead of doing all that, which you may write similar code in Java, you could use this approach, which looks kind of funky, but because of falsy values, it works. So first you test for your variable. If it's null, null, empty, or any of those 6 things, then that will be false. And so it's going to look for something true. So it used a logical OR statement. And then if it was false, then it will use this value to prime your variable. So this is a technique. It looks kind of hokey because you're like, oh, I would never think to do that. But this is what you see in JavaScript libraries. Like if you looked in the jQuery source code or other libraries, that's kind of the way they do that. So really the key point for the first several examples is just to know what the falsy values are. There's 6 of them. Just commit those to memory, and if it's one of those, it's false. If it's not, it's true. The next thing that you'll find kind of odd is you might want to use the double equals statement or the not equals, and that's generally considered a bad practice in JavaScript. They're there, but don't use them, because the double equals, not only it tries to figure out if the 2 values on the left and right are equal, but it tries to be smart. And so it's like it'll try to coerce each variable or each value. It tries to make them the same type. It'll convert them to try to make them the same type, and then it will test it, which gives you a lot of crazy values. So, for example, null equals undefined. Well, you wouldn't think that would be true, but using the double equals, it is true. And even crazier things like 0 equals a tab and a character return line feed. That's true. And those are things you probably don't want. And if you use that, your code's probably going to have a weird bug in it. So in JavaScript, there's something called the triple equals, which is it's called the identity operator. And the behavior of this one is probably what you expect. Like all these tests are false. Because that just makes sense to me, that 0 is not empty string. And so the triple equals, it doesn't try to convert the values into the same type. It just tests, is 0 the same thing as an empty string? No, it's not. Rock on. So to keep your sanity, use triple equals, and there's a not double equals, which is its counterpart. So this would be a simple thing that, unless you took time to learn JavaScript, you wouldn't know about this, and it could actually cause a lot of problems if you don't use it. So the key point is, technically there's some cases where you don't have to use the triple equals, but by doing it, it's not going to harm you. So just go ahead and do it. The next thing is declaring arrays and objects. You might be tempted to new up a new object or new up a new array, which technically you could do, but these were kind of added late in the game when JavaScript was made, kind of to appease Java developers because it looked more familiar to them. Behind the scenes, it's doing a couple extra steps. It's not necessary. There's a native way to do that in the language. And there's actually some cool things you could do with it, and I'll show you in a second. But to create a new object, you just say person equals curly brace, open brace, close brace. And to create a new array, you just use the square bracket. It's not a big thing, but it just shows that, well, there's some cool things you could do when you use them. So by using the curly braces, we could immediately initialize an object. We could create it and set its values. And so we're creating a person here using this native syntax. We could immediately set some properties, first name, last name, and actually set a function at the same time with its implementation. And if you use the native syntax for arrays, you could automatically give them values. You could have nested arrays. You could have multi-dimensional arrays. So by using this technique, it's a little bit better. Both of them will work, but the other one uses a lot more code, and it just shows that you don't necessarily know what's going on. So the best practice is to try to use the native ways to do objects and arrays. And, reserve the new keyword for your own custom constructors. Think of it like of a class or something, and we'll look at that in a little bit. The next thing you'll see Java developers tempted to do is try to use there's a for-in statement, which might be like a for each or something, where they try to loop over an array using this technique, and that's actually can get some weird problems. And so one of them, let's look at it. There's we're going to create a new array. In JavaScript, you could just set any, even though we didn't declare a length, you could just pick an index and assign a value to it. Now, what you'll notice, even though we have one value in this array, JavaScript says the length is 6 because that's the highest index you gave it. So if you use the for in array, it would only pick up the value that you put in it, which I'm guessing you wouldn't expect that. You might think it would go through each index, like 0, 1, 2, 3, 4, 5, but it doesn't. For an array, what you probably meant is just to use a standard for statement, priming your index and incrementing it each time. And this would be considered a more best practice for an array because it loops through all the indexes. Now, if you'll notice the indexes 1 through 4 are all undefined because we didn't set values for them, which is fine, but that's what I would expect, and that's what you should. That's the best practice for arrays, to use the standard for. Another problem of using the for in on arrays is a lot of JavaScript libraries. jQuery doesn't, but like MooTools, and there's Prototype is another JavaScript library. There's something called a prototype in JavaScript. Think of it like as a base class, maybe in Java, where you could like inherit some properties and values. And so, let's say this was MooTools, for example, and they added a property to your base class. Let's just think of that. The for in statement, if we looped over our array, would pick up whatever that library added to the array. So what you'll see a lot of other libraries, they'll add some helper functions to arrays to make it easier to do certain functionality. And so this is probably not what you expected. And so again, use the standard for statement. So the next thing is using the for in statement incorrectly on objects. You do want to use them on objects, but to loop over the properties, but you have to do something slightly special. You need to check that the key that you're looking at, the property that you're looking at, isn't on the prototype. You want to look at just the ones that you own, not the ones that you're inheriting from the prototype. And so by doing this extra check, you're making sure the property, you own it, and then you can deal with it. So let's look at an example of what that might look like to see the difference. So we're going to create a person constructor. Think of this kind of like a class in Java, where you can pass in first name, last name, and assign it. And then we can new up the person and pass in the values. We're also going to set a prototype. So for this person, we're going to set some properties that are inherited by all objects. Is married and has kids. So we're going to new up 2 people, and then we're going to loop over them 2 different ways. One, we're going to use the for in without the special if statement. And so you'll notice it picks up first name, last name, and then it picks up the prototype properties. But if you use the if check that has its own properties, when you loop over them, it'll only pick up first name and last name. Which in most cases, this is probably what you were wanting to do. You might have wanted to do this, but as long as you know the difference, you could do either way. So when it comes down to it, remember one thing. Arrays use the standard for, objects use the for in with the special if and check. This is huge. Most Java developers I know don't understand the difference between scope between Java and JavaScript. So Java has a block level scope. So anytime you see braces, you're confident that the variables within those braces are confined to that. But in JavaScript, scope is defined by the whole function. So let's take a look at this code, which works fine, but the person who wrote it didn't understand the difference. And so let's look at this. We have an eat function. Thankfully, we've already eaten, which has food of bacon, and he's hungry. And so it's going to test, are you hungry? Yes. And then it's like, and then it's going to wait 10 minutes, and then it's going to choose. But what you see here, since I just told you that JavaScript uses functional level, here's the beginning of the function, and then the end of the function is way at the bottom, like this is a subfunction. But he's declaring a variable here, thinking that it's going to remain in this scope, but it doesn't. Even though he's declaring var here, this scope for the if statement means nothing in JavaScript. Anything above it or below it or anywhere in this whole function could reference this variable. And so that's, in some cases, that's not going to hurt you at all, but we're going to look at some cases that it would hurt you. And so a better way to do this is to declare all the variables at the top of the function, like the first thing after the function, declare them, and then use them as appropriately underneath. And so that's why it's obvious to whoever sees it later about the scope. So best practice, declare all your variables at the top of the function. When I used to write VB6 code back in the day, this was considered the way to do it, declare all variables at the top. When I moved to Java or C#, it was considered best practice to declare as you need it, but don't do that in JavaScript because we're going to show some problems with that. So the next thing, and this piggybacks on the same topic of declaring everything at the top. If you don't declare at the top, JavaScript's going to do it for you. And it uses something called hoisting, and we'll look at that right now. So here is the similar type of code that we saw before not to do, where we have a say hello function, pass in a name, create a full name. We test it, and then someone declares a variable inside an if statement. That's considered bad. Now this code's still going to work. When you pass in Carlos Reynors, it's going to say hello Chuck Norris, because that's his real name. But behind the scenes, what JavaScript does is it will take all variables, no matter where they are, within the function, and it's going to hoist the declaration all at the top and declare them as undefined. It will keep the assignments where they were. So here's where I appended all of them, and it still assigns Chuck here, but all the declarations were shoved away at the top. Now, in this simple code snippet, both of them work just the same. We're not doing anything crazy, but you just need to know when it comes down to it, JavaScript's going to be doing this anyway. So here's a problem. Now, this won't actually run in Java, but here's a problem you could get in JavaScript. And actually, this would work in raw C code. But we have a nested for statement. We're using the same variable. So in raw C, I would be defined in this scope, and then this would be a local I. But what happens in JavaScript is it sees two variables. It hoists both of them to the top. So really, it's only one variable. And these will keep resetting each other over and over again, and this will be an infinite loop. So that could be a subtle problem where you might think, oh, that might work.
In a huge code where you don't see the other one.
Yeah, and this could be, somewhere. There could be a lot of code between this brace and this brace, and you could totally, if you're not splitting out your functions, your code and functions, this could be easily buried on, like, you have to scroll and stuff. So, okay, so this will take a little brain thought, but let's look through this, and we're going to see where we get into some problems, maybe in some real world situations. So we're going to print out a variable. You know, we're not declaring it or anything, and okay, well, it's undefined. That makes sense. I haven't declared it. Now I'm going to declare that same variable and give it a value. This is considered a global variable because it's just at the top. It's and global variables get stuck on the window. I don't know if you know that, but you could access some window dot some variable and it would print out 42. So we're going to print out the value and it gets 42. That's what we expected. That makes sense. So now we're going to call this function. The first thing we're going to do is try to print out that variable. But it was undefined. And the developer's like, what? It's undefined. I thought that was a global variable. I should have seen the value 42. I said it right here. What's up with that? And they get mad. And so they're like, okay, well, I'll give it a value. And then they print it out. I'm like, okay, well, that makes sense. It's 1. That's what I expected. But I still don't understand why this is undefined. So they go to print out the window some variable, which is the global, and it gives it 42. They're like, wait a second, I thought I just set some variable here. Why is it 42? Well, the reason for all this is somewhere deep down in your code, some guy saw an if statement and declared a variable called some variable, which conflicts with this name. So it goes, oh, well, this is going to be a local variable to this function scope. So what happens, due to variable hoisting, the declaration got shoved way to the top of this function, got set to undefined. So let's look at the how JavaScript interprets it. So what it did is it took that variable that was declared here, hoisted it way to the top of the function. So the first thing, it set some variable to undefined. So now this is local to this function. So when I try to print it out, well, it makes sense it's undefined because it got hoisted to the top as undefined. And so anytime I'm using it afterwards, it's using this local variable instead of the global one. So that's why when I printed out the global one, it was still 42 because we were never using it the whole time. But the trick was somebody stuck a var way down here. So again, best practice. Put all your variables at the top and you won't get into these problems. Okay, there's something also called function hoisting. And unfortunately, the rules are slightly different. But once you learn them, then they make sense. So let's look at this. The very first thing, I'm going to call a function called say hello. I get an error because, well, that's not defined. You're like, okay, well, that makes sense. I haven't declared the function, so when I call it, it's not there. So then I call it, try to say goodbye. But it works. You're like, wait a second. If this one doesn't work, why does this one work? I'm not declaring any functions above it. But what happens is there's actually two ways to declare a function. One's called a function expression, which you set a variable and set it to an actual function. Another's called a function statement. And you possibly might be more aware of this one, where it starts with the word function. You'll see this all over the internet. And it's not bad, it's just different. But and then you give it a name. So what happens behind the scenes is the function expression looks very much like what we're used to, what we showed the last couple times. And what happens is it uses the same rules. So it's a variable, so it's going to use a variable hoisting. So it hoists the declaration way at the top, but keeps the assignment here. But the function statement, if you see something that starts with a function, JavaScript will actually take the whole thing and move it all to the top, both the declaration and the assignment. So let's take a look what that looks like. So behind the scenes, JavaScript, in both cases, will shove them way at the top. JavaScript also hoisted the whole function of say goodbye to the top. So that's why when we called say goodbye here, it worked. But with the variable expression, or the function expression, it kept where it was. So that's why that didn't work. And so really a lot of the articles that you see, people use the function statement because they know wherever they put it, it's going to be shoved the whole thing's going to shove to the top and work regardless. So that's the main difference. So again, I reiterate, always declare all your variables at the top of your function. If you do, you won't see any of these problems that I just addressed. Like, all of them go away. You don't have to worry about it. Because it's a confusing thing. The next thing is not using closures correctly. We're going to take instead of explaining it initially, we're going to show an example of a bug that's kind of strange, and we'll talk about how to resolve it. So this is a little bit of jQuery. I don't expect you to know jQuery too much. I'll just explain it as I go. We're selecting an unordered list, and then we have a for statement that loops over that loops 10 times, and it will create a list item. Give it the ID of the index, and give it a text that says, say link 0, link 1, link 2, etc. The developer meant when they clicked it to say you've clicked 0, you've clicked 1, you've clicked 2, you've clicked 3. If we run this, This hokey, I have to do it again. If we run it, there we go. So it did print out these things, but if I click any of them, it gives me the same result. Click 10, you click 10, you click 10. And why it's doing that is because you're not actually running the function until a point later in time. And so at that point in time, the value I, once it gets out of the loop, is 10. So as far as this code knows, I is always 10. And so it's going to click, you click 10, you click 10. So what we wanted to do is capture the value at the time we built up this function so that it would actually print out the value at that point in time. The way we solve that is to use a closure. Closures are confusing. If you don't know what a closure is, you may or may not understand it after I explain it, because for most people it takes numerous times to think about it, to play with it, to make mistakes. But let's try to quickly go over it. So this is a source code from the Mozilla Developer Network, and which is a great resource. It might not be beginner because it's kind of complicated, but so what we have a make adder function, and it actually behind the scenes returns a function. So this already looks kind of funky, but this is the type of thing you need to do to create a closure. So I'll explain what it does. We're going to call make adder and pass the value 5. So that gets shoved in here. So we're passing 5 in here, and then we're going to return a function that accepts another parameter, but uses internally what we passed in. And so it will actually, when this function returns, it will remember what the value of x was after the fact. So what we're going to do is we're going to call add 5, just so it makes a little bit of sense later. And then we're going to make another one, passing the value 10. It's going to return a function, and it's going to remember that value that we gave it, which is 10. And then we're going to store it in another variable. So these are both functions now, because I returned a function. So I could call these. So now I'm going to call the first one, add 5, and pass it 2. So it shoves the 2 into this inner function. And it's going to take 2 plus the value that it remembered. It enclosed memory around the value of x previously. And so it's going to add them together and make a 7. And the same one before, we're going to take our function, add a 2. It remembers 10 was the value of x, and it will give you 12. In order to try to make more sense of this, I made a diagram. It may or may not make sense, but we'll quickly show it.